Hello, in this video I'll be working through Unit 3 homework problems 38 through 43, and today we're focusing on the chain rule. Number 38 says the graph of h of x is shown below. Find the equation of the tangent line to the graph of p of x equals square root of h of x when x is negative 4. So we have our equation for p of x. P of x equals the square root of h of x. In order to find the equation of the tangent line, I'm going to need to find two things, p of negative 4 and p prime of negative 4. So let's start by finding p of negative 4. For p of negative 4, we simply substitute negative 4 in for the x, so we get square root of h of negative 4. And h of negative 4 we can read from our graph. H of negative 4 is positive 4. It's that point right there. So that's equal to the square root of 4, which is equal to 2. So that tells me my point of tangency is negative 4, 2. Now to find the slope of my tangent line, I find p prime of x and then p prime of negative 4. So if p of x is the square root of h of x, I'm going to think of that as the square root of stuff. Then my derivative is 1 over 2 square root stuff times the derivative of the stuff. So 1 over 2 times the square root of h times h prime. And now we can find p prime of negative 4 by substituting negative 4 in for x. So I have 1 over 2 square root h of negative 4 times h prime of negative 4. And 1 over 2 times the square root of h of negative 4 is 1 over 2 times the square root of 4, so 1 over 2 times 2, times, and h prime of negative 4 is the slope of h at negative 4. So the slope here, if we just look at rise over run, down 1, right 2, is 1/2, negative 1/2, negative 1/2. And so we get negative 1/8 for the slope of our tangent line. And then putting all of that together, the equation of our tangent line is y minus 2 equals negative 1 over 8 times x minus negative 4, or x plus 4. Number 39, let f and g be differentiable functions whose values are shown in the table below. Part A is the graph of h equals f of g of x increasing, decreasing, or at a relative max or min when x equals 3. So in order to answer that question, we want to know if the derivative of h is positive, negative, or 0. So we're going to find h prime of x. H prime of x. In order to find the derivative of h, we're going to have to use the chain rule because h is a composite function, f of g of x. G of x is my inside function. F of the stuff is my outside function. So my derivative, h is, I'm thinking of h of x as f of stuff. So the derivative of f of stuff is f prime of the stuff times the derivative of the stuff. So f prime of, and I wrote that incorrectly. Let's erase that. F prime of stuff is just f prime of g of x times g prime of x. And now we want to know what's happening with h prime of x when x is 3. So h prime of 3 equals f prime of g of 3 times g prime of 3. And we can go to the table to find those values. G of 3 equals 4. So I have f prime of 4 times g prime of 3, and g prime of 3 equals 6. F prime of 4 equals 8. So this is 8 times 6, or 48. 48 is positive. So since h prime of 3 is greater than 0, we know that h is increasing at x equals 3. Part B, if p of x equals g of 2x, what is the value of p prime of 1? So before we find p prime of 1, we need to find p prime of x. P of x equals g of 2x. That's a composite function. This is g of stuff. So the derivative of g of stuff is g prime of stuff times the derivative of the stuff. And the derivative of 2x is 2. So now to find p prime of 1, we substitute 1 in for x. It's g prime of 2 times 2. And g prime of 2 is negative 1. So negative 1 times 2 is negative 2. Part C, if q of x equals square root of f of x plus g of x, what is the value of q prime of 4? What does this value say about the graph of q when x equals 4? So before we find q prime of 4, we need to find q prime of x. So we're going to take the derivative of q of x. And q of x is in the form of square root of stuff. So the derivative is 1 over 2 times the square root of the stuff times the derivative of the stuff. So the derivative of f of x plus g of x. And the derivative of f of x plus g of x is f prime of x plus g prime of x. Now to find q prime of 4, we substitute 4 in for x. So I have 1 over 2 times the square root of f of 4 plus g of 4. And I'm going to multiply that by f prime of 4 plus g prime of 4. So we get 1 over 2 times the square root of f of 4 is 1, g of 4 is 7, and then f prime of 4 is 8, plus g prime of 4 is negative 2. Okay, so that's 1 over 2 times the square root of 8 times 6. And that's 3 over the square root of 8, and the square root of 8 we can write as 2 square root 2. And this derivative value is positive, so we can say since q prime of 4 is greater than 0, q is increasing at x equals 4. Number 40, consider the basic functions f of x equals x cubed and u of x equals sine of x. Let h of x equal f of u of x. Find the exact instantaneous rate of change of h at the point where x equals pi over 4. So the instantaneous rate of change of h is h prime of x. And to find that, we're going to take the derivative of h of x. H is a composite function. It's f of stuff. So the derivative of h is, the derivative of f of stuff is f prime of the stuff times the derivative of the stuff, u prime of x. And we want to find the instantaneous rate of change right where x equals pi over 4. So now we find h prime of pi over 4. So that will be f prime of u of pi over 4 times u prime of pi over 4. U of pi over 4 is the sine of pi over 4, and that's 1 over root 2. So I need f prime of 1 over root 2 times, and then u prime of pi over 4. Well, I haven't found u prime of x, so let's do that. U of x equals sine x, so u prime of x equals cosine x. And now u prime of pi over 4 is the cosine of pi over 4, which is also 1 over root 2. Now we need to find f prime of 1 over root 2. I haven't found f prime of x yet, so let's do that. F of x equals x cubed, so f prime of x equals 3x squared. And then f prime of 1 over root 2 would be 3 times 1 over root 2 squared. That's 3 times 1/2, or 3/2. So we have 3 over 2 times 1 over root 2, and that's 3 over 2 root 2. Part B, which function is changing most rapidly at x equals 0.25, h of x or r of x? To find out how quickly they're changing at a specific value of x, we look at the derivative. So we're going to find h prime of x and we're going to find r prime of x, and we'll compare their values when x is 0.25. H prime of x is the derivative of h, and h is in the form of f of stuff. So our derivative is f prime of the stuff times derivative of the stuff. So f prime of u of x times u prime of x. And then at x equals 0.25, h prime equals f prime of u of 0.25 times u prime of 0.25. And using our calculator, well, first let's write that out in function form. So it's f prime of, and then u of 0.25 is going to be sine of 0.25 times u prime of 0.25, and u prime of x is cosine x, so this will be cosine of 0.25. And then f prime is 3x squared, so we have 3 times the sine of 0.25 squared times the cosine of 0.25. And now going to the calculator, this should give us 0.178. Okay, let's compare that to r prime of x. So r prime of x, r of x is u of stuff, so the derivative of r is u prime of the stuff times derivative of the stuff. So u prime of f of x times f prime of x, and we're going to evaluate that when x is 0.25. So we get u prime of f of 0.25 times f prime of 0.25. And f of 0.25 is 0.25 cubed. So we're going to need u prime of 0.25 cubed times f prime of 0.25, and f prime of x is 3 times x squared. So we need 3 times 0.25 squared. Now u prime is equal to cosine, so we need cosine of 0.25 cubed times 3 times 0.25 squared. Okay, and now we can go to the calculator, and this gives 0.187. So r prime of 0.25 is greater than h prime of 0.25. And this tells us that r is changing more rapidly. 41. Let f of x be a differentiable function. For each of the following, determine the derivative. Part A, g of x equals e of f of x. No, e to the power f of x. So our derivative, g prime of x, g is in the form of e to the power stuff. So the derivative of e to the stuff is e to the stuff times the derivative of the stuff. And since we don't have specific functions for f of x, we're just going to have to leave our answer in this form. Part B, h of x equals f of e to the power x. So h prime of x equals the derivative of our outside functions, f prime of e to the x, times the derivative of the inside function, e to the x. Part C, j of x equals cotan of f of x. So j is in the form of cotangent of stuff. Our derivative, j prime of x, derivative of cotangent stuff is negative cosecant squared stuff times derivative of the stuff. So times f prime of x. Part D, k of x equals f of cotan x. So k is in the form of f of stuff. The derivative will be f prime of stuff times the derivative of the stuff. So now times the derivative of cotangent, which is negative cosecant squared x. Part E, m of x equals f of x to the power 4. So this is in the form of f of stuff. The derivative, m prime of x, equals f prime of stuff times the derivative of the stuff, 4x cubed. And f p of x equals f of x to the power 4. So this is in the form of stuff to the power 4. P prime of x will be 4 times the stuff, f of x, to the power 3. So if we stick with this notation, I can put the 3 after the f, although that looks a little weird, so I'm just going to use brackets and raise it to the power 3, times the derivative of the stuff, so times f prime of x. Number 42, let functions p and q be the piecewise linear functions given by the graphs below. Let c of x equal p of q of x. Find c prime of negative 1 and c prime of negative 2. So first let's find the formula for c prime of x. C is a composite function. It's p of q of x, so p of stuff. The derivative will be p prime of the stuff times derivative of the stuff. So p prime of q of x times q prime of x. Now to find c prime of negative 1, we just substitute negative 1 in for x. So we have p prime of q of negative 1 times q prime of negative 1. So q of negative 1, if we look at the graph for q, at negative 1, q is equal to 2. So p prime of 2 times q prime of negative 1. Now p prime of 2 will be the slope of p at 2. So the slope at this point is 2 times, and then q prime of negative 1. So at negative 1, we look at the derivative or the slope of q. But at negative 1, this derivative doesn't exist. That's a corner point. Does not exist. So this whole thing does not exist. Okay, well, let's see if we have better luck with c prime of negative 2. C prime of negative 2 will be p prime of q of negative 2 times q prime of negative 2. So q of negative 2, we look at the graph of q at negative 2, looks like we're at negative 1. So p prime of negative 1 times q prime of negative 2. P prime of negative 1 is the slope of p at negative 1. At negative 1, we're at a corner point, so this does not exist. So c prime of negative 2 also does not exist. Part B, find a value of x for which c prime of x does not exist. Explain your thinking. Well, in the previous problem, we already found 2 values where c prime doesn't exist, but let's see if there are any more. So anywhere q prime of x does not exist, c prime of x does not exist, because q prime of x is part of the formula for c prime of x, and q prime of x does not exist at these corner points, so when x is negative 1 and positive 1. So if x is negative 1 or positive 1, c prime of x does not exist. But we're also going to have a problem if we try to find p prime of negative 1 or p prime of 1, because p prime does not exist at negative 1 and 1. There are corner points there as well. So p prime of negative 1 is going to occur if q of x is equal to negative 1, since we're taking p prime of q of x. So now the question is, where does q of x equal negative 1, and where does q of x equal positive 1? Q of x equals negative 1. Let's see. Q of x equals negative 1 right here when x equals negative 2. When x is negative 2, q of negative 2 equals negative 1. So when x is negative 2, we'll add that to our list. And then where does q equal 1? Q equals 1 here at positive 2, and here, and we'll just estimate that to be about negative 1.4. Okay, so we have 5 values of x where c prime will not exist. So x equals negative 2, negative 1, negative 1.4, positive 1, and positive 2. Part C, let y of x equal q of x and z of x equal q of p of x. Determine y prime of negative 2 and z prime of 0. So y prime of x, we're going to take the derivative of y of x, and y is in the form of q of stuff. So the derivative will be q prime of stuff times the derivative of the stuff. So q prime of q of x times q prime of x. And then y prime of negative 2 will be q prime of q of negative 2 times q prime of negative 2. Q of negative 2, we'll read from the graph. So q of negative 2, we look at the graph of q. When x is negative 2, we're at this point right here, so it's negative 1. So we need q prime of negative 1 times q prime of negative 2. So now we look at the slopes. The slopes of q when x is negative 1, well, q prime of negative 1 does not exist. So this whole thing now does not exist. Okay, so let's see what happens with z prime of 0. First, we'll find z prime of x. Z of x is in the form of q of stuff. So the derivative will be q prime of the stuff times the derivative of the stuff. So q prime of p of x times p prime of x. And we want z prime of 0. So we need q prime of p of 0 times p prime of 0. P of 0, we'll look at the graph of p, and when x is 0, we're at negative 1/2. So I need q prime of negative 1/2 times p prime of 0. So now let's look at those slopes. On the graph of q, when x is negative 1/2, so right here, if we follow that up to the graph of q, the slope is 0. So 0 times p prime of 0. And p prime of 0 will be the slope of p when x is 0, and it looks like that is 1/2. 0 times 1/2 is 0. 43. If a spherical tank of radius 4 feet has h feet of water present in the tank, then the volume of water in the tank is given by the formula V equals pi over 3 h squared times the quantity 12 minus h. At what instantaneous rate is the volume of water in the tank changing with respect to the height of the water at the instant h equals 1? And what are the units on this quantity? Well, let's simplify our equation for V. So V equals, I'm going to distribute the pi over 3h squared. So pi over 3h squared times 12 is 4 pi h squared minus, and then pi over 3h squared times the h will be pi over 3h cubed. And we want to find the rate of change of volume with respect to height. So I want to find dV dH. So I'm taking the derivative with respect to h. The derivative of 4 pi h squared, the 4 pi is constant, so we can use our constant multiple rule and our power rule for h squared. The derivative of h squared is 2h. So 4 times pi times 2 times h is 8 pi h. Minus, and then pi over 3 is constant, so we'll multiply pi over 3 by the derivative of h cubed. The derivative of h cubed is 3h squared. So pi over 3 times 3 is pi, and then h squared. Now we want to know this rate of change at the instant when h is 1. So I want dV dH when h equals 1. So that'll be 8 times pi times 1 minus pi times 1 squared, which simplifies to 7 pi. The units on this quantity will be the units for V per the units for H. So the units for V, my volume, is cubic feet, and the units for H are feet, so cubic feet per foot, cubic feet per foot. Part B, now suppose that the height of the water in the tank is being regulated by an inflow and outflow, so that the height of the water at time t is given by the rule h of t equals sine of pi t plus 1, where t is measured in hours and h is measured in feet. At what rate is the height of the water changing with respect to time at the instant t equals 2? So now we have our equation that relates h and t. H of t equals sine of pi t plus 1. We want to find the rate of change of height with respect to time, so we're looking for h prime of t. The derivative of sine pi t, to be clear, it's the sine of pi times t. So this is the sine of stuff. The derivative of sine of stuff is cosine of stuff times the derivative of the stuff, and the derivative of pi t is pi, plus the derivative of 1, which is just 0. Now, at the instant when t equals 2, we need to find h prime of 2. So that would be the cosine of 2 pi times pi. And the cosine of 2 pi is 1. 1 times pi is pi. Now for units here, what we were finding was dh dt. So we want the units for h per units for t. T was measured in hours, h was measured in still feet, right? So this will be feet per hour, pi feet per hour. Part C, continuing under the assumption in B, at what instantaneous rate is the volume of water in the tank changing with respect to time at the instant t equals 2? So this time we want the rate of change of volume with respect to time. In other words, we want dV dt. So in part A, we found dV dH, the change in volume with respect to the height. And in part B, we found dH dt, the change in height with respect to time. Notice if we multiply these together, the dH's will cancel out and leave us with dV dt. So we just want to make sure we're finding these at that same moment in time, and then we can calculate dV dt simply by multiplying dV dH times dH dt. So we want to know dV dt at the instant when t equals 2. Well, dV dH didn't have our equation for that did not have a t in it. So we need a way to relate h and t. What was the height at time 2? Well, we had an equation for h and t. We know h of t is the sine of pi t plus 1. So at the instant when t equals 2, h of 2 is sine of 2 pi plus 1. And the sine of 2 pi is 0, so this is equal to 1. So when t is 2, h is 1. At t equals 2, h equals 1. Okay, so that means to find dV dt, when t is 2, we're going to find dV dH when h is 1 and multiply that by dH dt when t is 2. So dV dH when h is 1, that was our answer from part A. That was our 7 pi. And we're going to multiply that by dH dt when t equals 2. I wrote that a little bit funny. Let me fix that. When t equals 2. There we go. That looks better. So dH dt when t equals 2, we found that to be pi. And so our answer dV dt will be 7 pi squared. And to get our units, we take the units for V per the units for T. So the volume was measured in cubic feet, so feet cubed, per, and then time T was measured in hours. So our answer, 7 pi squared cubic feet per hour. Part D, what are the main differences between the rates that we found in Part A and in Part C? And include a discussion of the relevant units. So we did address that. In Part A, the volume was increasing at a rate of 7 cubic feet per 1 foot increase in height. And in Part C, we found that the volume was increasing at a rate of 7 pi squared cubic feet per 1 hour increase in time. So they were both measuring how quickly the volume was changing, but one was with respect to height and one was with respect to time.